Hello, welcome to another episode of the Minecraft clone tutorial series. Today I'm going to be showing you how to draw multiple blocks. Sorry for the lateness of this video, by the way. I was graduating, so I had to take a bit of time off, but now we're back into it. So let's go ahead and get started. So we first have to get some errors out of the way. Not errors with the code, but errors that you could have when trying to draw multiple blocks. So probably the simplest way and the way that you would assume to do it would be to simply change the model matrix, remember that's the actual position in world space, and then just draw it again. And so let's go ahead and show that real quick. So first we'll run it and see that we have our simple project working. That's my first time running it, so it's taking a second, but here we have our simple cube and it's spinning around and all that. So that's pretty good. We got that working. But let's go ahead and draw this a second time with a different model matrix. So I'll just go below this and I will just change this model matrix again. We will do this model matrix here, redefine it as matrix.identity. Or what I'll do is I'll actually do plus equals matrix4 dot create translation. And then I will send it the new vector 3, and then I'll move it over by 2, 0, 0, just so it's moving a little bit. And then I would simply reapply or resend this uniform variable and then draw my object a second time. So now I'm doing 2 draw calls for these 2 blocks. And if all goes well, yeah, we have our 2 blocks. And it's really distorted because of the order. The rotation and translation are not properly set up. I was just making a little example of how you can do you can draw things at multiple locations. The problem with this is that we are making a Minecraft clone. And one thing about Minecraft clones is they have to be efficient. And this is because of the amount of things that we're drawing. So let's just take, for example, to put into perspective, let's take one chunk. I believe in Minecraft, one chunk is 16 blocks by 16 blocks by 256 blocks. So if we do the math here, we do 16 times 256, then a chunk can be up to 65,536 blocks. So the problem with this method of translating them for every single block is that you have to do this for every frame. And a draw call is very expensive in OpenGL and OpenTK. You want to absolutely minimize your draw calls. So imagine that you're making 65,536 draw calls per frame. I don't think it takes a very strong imagination to see that that is definitely a problem, given that that is only one chunk and we need multiple chunks. So with that being said, let's talk about the solution for this. So the solution that we're going to be using, that Minecraft itself uses, is what's known as chunk meshing. And so what this is we define the original block data as we did at the top. And then what we do is when we create these blocks, we'll have a block class, and this block class will have its own position, and we will physically change the data of this block to move it from its original spot over here to over here. And we can get away with this because we don't rotate our blocks ever in a voxel game. Voxel games never have like rotating blocks. So we can do this sort of translation very, very easily. And then our model matrix will not be the one translating. Instead, it will just draw it at this location. And so we do this with all of our blocks. And then we have a cool little scene like this, where all of our blocks have their own unique positions whenever they are created. And then on top of this, we can do what's known as chunk meshing. And chunk meshing is basically where we will be taking this chunk, which will have a ton of blocks. So we can have like all of our blocks here. And normally you have all these blocks, and these are not really good blocks, but it's the example I'm giving, how you can see how all these blocks have all of their faces, and see all of these, this player here, let's say the player's like right here, and the player's looking here, it can't see any of these faces over here in the inside. So what the chunk meshing does is it uses some algorithms, and then these algorithms basically remove the faces that are not visible to the player. And so that is what we are going to hopefully end up completing by the end of this drawing multiple blocks tutorial. Now this is going to be multiple parts. We're not going to cover the chunk meshing in one part. All right, so now that we have our objective down, let's go ahead and get going with creating a block class. And the reason I'm going to be creating a block class is because it's not good practice to have your entire render pipeline in your main game file. And the reason is because if you want to have another one, then you got to do that all over again. So one of the approaches that's very popular that I'm going to be using is object-oriented programming, and I'm going to be abstracting this render pipeline into different classes to make it easier to work with in large scale. So I'm going to right click on the project, add, and then I'm going to add a new folder. I'm going to call this graphics because this is going to contain our entire render pipeline. I'm going to add a new item and I'm going to call it vbo.cs. This is going to have our VBO. And so here we need some constructors. So first one we need is we need a list of vector3. And this is for our vertices, just our vertex positional data. Then we want a second constructor, and this one's going to be of type vector2, and this is for our texture coordinates. And so we're going to have multiple constructors so that our VBO can take in multiple different types of data. And down the road we might change this, but these are the only two that we need right now. So now all we need to do is we need to create a public unsigned integer ID. And then what we can do is inside this method here, we can do id equals gl dot, and we have to import OpenGL as well. So using OpenTK dot graphics dot OpenGL4, I believe, yeah. id equals gl dot gen buffer, and then we do cannot explicitly convert from int. Maybe it's just int. Is it just int? Huh. Okay. And then now we need to do gl dot bind buffer, and this is going to be buffer target dot array buffer, and then we're binding the ID that we just created. This is all the stuff we did before. So gl dot buffer data, and then all we're going to do here is we're going to do buffer target array buffer, and then we need the size, and the size is going to be the data dot size or data dot count multiplied by the size of a vector. Oh wait, actually we want this. We want the size of vector3 dot size in bytes, and then we need the data itself, which is just data. Actually, it's data dot to array because we're using a list, and then the buffer usage hint is going to be static draw. So buffer usage hint dot static draw. So that's all we need to do for this. And now all we have to do is just simply copy this over to the vector2 one and change one thing. So vector2 dot size in bytes. There we go. All right, now we need to add some convenience methods here. So I'm going to do public void bind, and this is going to take 0 arguments, and we can literally put it on one line. We can do gl.bind buffer, and this is going to be buffer target dot array buffer, and then we're going to bind our ID. And then you don't really need to unbind VBOs, but we can do it just in case. So let's unbind this just in case. And then one that we do need is the public void delete, and this is going to do gl.delete buffer, and then we send in that ID. And that's pretty much all that we need for our VBO class. So let's go ahead and create the VAO class now. So now we're going to do VAO.cs. And this one is going to import that VBO one. So I think it's using, or we can just do this. So that we're going to have an empty constructor for this. We don't need anything. And then we need a public void link to VAO. And then what we need to do is we need to do a VBO. We actually need to do this. We need to do int location, int size, and then VBO. And then what we can do is we can do a stride and a step, but we will handle that in a little bit because right now our data doesn't need that. But once we do make it so it needs that, we will put that in. So now we need also a public int ID. And in the VAO constructor, we'll just generate this. So id equals gl dot, we need to import OpenGL again. So I will do using OpenTK dot graphics dot OpenGL4. And then we need to do gl dot gen vertex arrays, or it's just gen vertex array, I believe. And then all we need to do is we'll just make it so that we bind it immediately upon constructing it. And just to be safe, we are also going to be binding it in this link to VAO. And we could just do this again, but I'm going to actually create the methods ahead of time. I'm going to do public void bind, and this is going to just do gl.bindVertexArray. IntelliSense is very, very smart right now. And then unbind is just gl bind vertex array to 0. Unbind. I don't know if unbind is 2 words or not, so I'm just putting it all with just a capital in the beginning, but it doesn't really matter. It's a convention. Public void delete. gl.delete vertex array at id. All right, so that's all we need to do. And now what we can do is we can just do bind, because we want to make sure that our VAO is bound when we do this. And then what we want to do is we want to do vbo.bind. And then what we want to do is we want to actually do all of our stuff. So what we're going to do is we're going to do gl.vertex attrib pointer. And this is going to take in the location, the size, and then we need the type, which is vertex attrib point type dot. And then we're going to do a float here. I think all of ours are going to be floats. And then the normalize is false. And then the stride is 0, and that is also 0. And then all we do is we can unbind here, but I don't think we need to. We can just do unbind. We can unbind the VAO though, just in case we have multiple VAOs. But I don't think we need to unbind the VBO. So now all we have to do is the last thing is gl.enable vertex. I think it's array attrib, or is it attrib array? It's attrib array. Whoopsies. And then at the location. And you can know that it's attrib array from looking at the arguments list. It'll say only the location. That's all we need. So that's everything for the VAO. So let's do the IBO. I'm going to call it IBO, the index buffer object. And this could definitely just be a VBO, but I like to put it in its own thing because there's just slightly different stuff that you do. So public IBO, and this is going to take in a list of unsigned integers, and it's going to be data. I'm going to call it data. And then we need also an ID. So we're going to do public int ID. And then we're going to do ID equals GL dot. Oh, I need to import this. Okay, using OpenTK.graphics.OpenGL4. Oh, just realized this is an interface. Why is it an interface? That's weird. Okay, change it to a class. Now we need to do ID equals GL.genBuffer. All the same there. But now we need to do gl.bindBuffer and then buffer target dot element array buffer and then the ID and then gl.buffer data, and then this will be buffer target dot element array buffer, and then the next one is the size, which is going to be data dot count multiplied by the size of an unsigned integer, and then we need the buffer usage hint, or no, we need the data itself, which is data, I believe, yeah, data, and then we need the buffer usage hint dot static draw, so we're going to be drawing it all the time. We need data.toArray because we're using lists, and the reason we're using lists is because lists don't have a defined size upon initialization, so you can add to them as you go along, which is very useful in a game like Minecraft where you're constantly adding and breaking and, you know, blocks and stuff like that. So that's why we're doing that. So now all we have to do is we just do public void bind, and it's all the same process. So gl.bindBuffer, and this is going to be buffer target.element array buffer and ID. So you can see why we have to make a separate class for the IBO because it's an element array buffer. Now unbind here, and then delete, public void delete, gl.delete buffer ID. Okay, that's our IBO. Now we can go ahead and do some different things. Let's go ahead and make a texture one. This is where it gets a little bit harder. So texture.cs. And then let's go ahead and split this up so we can see both the game and the texture as well. All right, so here we are creating our texture stuff. So what we're gonna have to do is we're going to create a public int ID. We're going to do a public texture, and this is going to take in a file path. Oh, why did I do that? String file path. I don't know why I wrote a hard-coded string named file path there. Okay, now what we have to do is we don't have to do a lot of different stuff in the texture because we already know like the parameters we want for Minecraft. We don't ever want to change that because we want continuity with how we are drawing things. So here what we're going to do is we're going to do id equals gl dot, we need to also import OpenGL. Oh boy, OpenTK dot graphics dot graphics dot OpenGL4 id equals gl dot gen texture. Okay, and then we can literally just copy all this stuff over here from the game because we don't need to ever change that. The only thing we need to change is we need to make sure this texture ID is now our ID. The reason we're just putting ID for all these is because when we reference this, we're going to reference it by the object name .id. So we don't need to worry about having a special name for all these. So now after doing all that, we can simply, we can do some cool stuff here. So what we're going to do is we need to import STB image to this. So I'm just going to take that import from over here. So using STB image sharp, not blow up the whole thing. Since now we don't need it in that main game file, we can just cut and paste it. And now we can do some cool stuff. So let's go ahead and load the image itself. So here we are just copying over that code, making sure that everything is the same. And then we need to copy over one more thing. I'm actually going to delete it from here. Delete it just to make it easier on us later. Now I'm going to get all this stuff here and just cut it and then do this. And now the last thing, now that we are done with all that, let's go ahead and just delete it from the onload. And then let's re-put this back here. Go back to our texture.cs and let's add some more convenience methods. So public void bind. This is going to just have this here, bind texture. And I think the next one is the ID. And then we need an unbind, which is this. And then we'll do unbind here. And we are going to be unbinding after doing all this because we are going to be creating and loading a lot of textures all at once. And so it just makes a little more sense to unbind it after we create the whole texture. So now all we need to do is delete. So we'll do public void delete. This is gl.delete texture. And this takes in just the texture ID. That's it. Cool. All right, so that's our texture one done. Let's go ahead and get the ShaderProgram one done. I think that's basically it for roughing out the subclasses that we're going to be using in our block class. So this one I'm going to call ShaderProgram.cs. And here we're going to take in a public shader. We're going to have it in our constructor, ShaderProgram. It's going to take in a string for the vertex shader and a string for the fragment shader. And then here we're literally just going to copy our code. So let's go back to this game.cs and let's put it on the side here again so we can reference it. And there's a lot of stuff here, but we can just do whatever with this. So all we're going to do is we're going to have, we don't need to ever reference these individually, these vertex shader and fragment shader, so we can declare their integer IDs in the constructor because we don't need to access them in other methods. So we'll just do int vertex shader. I'll actually just copy it over. Let's see if we can do every single thing immediately like this. If we just cut this over and we do this, and then we just make sure that we have an int shader program here, or actually int ID. So let's do public int ID. And then we'll do ID equals, and then we'll also import graphics, so OpenTK.graphics.OpenGL4. That should be most of everything. Oh yeah, well we can't call them the same thing. So what I'll do is I'll do vertex shader file path, and then I'll do fragment shader file path here because we had the same names there. That wasn't good. And now just change a couple things here. So we're attaching it to this our ShaderProgram ID, and then we're linking our ShaderProgram ID. And then here for these, we're going to change this over to our files here. But you'll notice that the load shader source doesn't exist. That's because we have our load shader source in our actual main game class. So let's just go ahead and move that over. So we can, I'm pretty sure we can just cut it and put it right here and nothing will happen. Yeah, there you go. And this will just take in that file path. And now we have no errors. And so now we just need some convenience methods. So let's go ahead and put this game class back where it was, and then do public void bind. Why did I put bind texture? Okay, I'm slightly losing my mind here. gl.useProgram, and then we need to do the program itself, which is the ID. And then we need to do gl.useProgram, and then we can just do 0 here. And then we can do gl.delete shader, and this is just going to take in the shader itself. Okay, sorry about that. I just got carried away there. Yeah, okay, they are correct there. All right, so we have all that. That's pretty cool. So now we can just go into our game class, and basically this entire pipeline here, we can just remove it because we don't need it. So that's basically all we need there. Let's just go ahead and get rid of this. And then what we'll do is we'll just create our stuff. So in the instance here, we're going to get rid of all these IDs, and we're just going to create some stuff. So I'm going to just create like a VAO here. So VAO. This is just because we need it in the methods later. So VBO. And then I think we need the IBO. Oh, we don't need the VBO right there. Let's go ahead and just leave it out. So IBO, and then ShaderProgram. I'm gonna call it just program. And then and then we need the texture. Okay. And now what we need to do is get rid of also the unload, and we will simply do VAO equals a new VAO, and this just takes in nothing. And then what we can do is we can do VBO equals a new VBO, and for now we're just going to send it our data. I believe it's in a list of vector3 already. Awesome. So now we can send in our vertices. And we also need to make sure we're using the variable VBO. Did I call? Oh, I didn't create one. That's why. VBO. And then all we need to do is we need VAO.link to VAO. We want this in the first location of the VAO, and then the size is 3 because we're using a vector 3. And then we need the VBO itself. And then we need to create an IBO. So we're going to do an IBO. Actually, we already have one. So IBO equals a new IBO. And this is going to take in the data, which is going to be our indices. And our indices is of type array, which we want to change to list. So list of unit indices. And this needs to get a new list of unit. That's all we need to do. All right. And now we don't need to link this to the VAO because we just bind it. All we need to do now is create our shader program and create our textures. So I'm going to create our shader program first. So shader program. Oh, we already have our program. So program equals a new shader program, and this is going to take in the vertex file and the fragment file. So I'm going to do default with a lowercase d, no, uppercase d, default.vert, and default.frag. Okay, and then what we're going to do is we'll just do the texture now. So I'll just do texture equals a new texture. This is going to take in the file path. And I think all we have to do is specify the name. I think I already did the rest of the file path for it. Yeah, I did. Except I'm hard coded in the name here. What you want to do is you want to put this in like this. So you do plus that file path there. There we go. Okay, now that we're actually using the file path, now in the onRender frame, we can do we'll do program.bind, binding our shader program, and then we'll do VAO.bind, and then we'll do IBO.bind, and then we'll do texture.bind. Awesome. Get rid of all this stuff. And now what we need to do is we need to change this stuff. So what we'll do is we'll do program.id, and later on we will add some convenience methods to make it so we can get this location from within the class, so we don't have to do this ourselves. I think it's a little too much for this video here. This is just part 1. Program.id, and then we want indices.count here instead of length because we are using a list now. So that should be it. Well, actually, we have to call all the deletes. So vao.delete, ibo.delete, and then we can do texture.delete, program.delete. And I did not scope my VBO, so I could do that, but it doesn't matter. We'll do that in a bit. Let's just make sure that this actually runs. So first we'll build it, and hopefully it doesn't blow up. Oh, it's taking a second. Okay, that was scary. Now if we run it, we're seeing a black box, so this probably means that we weren't able to load our shader programs in correctly. We're taking in these files. Yeah, I did not. I put that as vertex shader. There we go. Okay, that's a very quick fix. Make sure all that stuff is working. Cool. Okay, so it's working except the texture is not loading correctly. I never even specified the texture coordinates. Okay, that's rough. That's a rough way to do this. Okay, so let's actually do that real quick. Let's create our texture coordinate VBO. So let's do VBO. I'm gonna call this UV VBO equals a new VBO. That's embarrassing. Send in our texture coordinates, and then we'll do VAO.link to VAO at 1, size of 2, and then the UV VBO. And that's all we need to do. 2 lines of code. There we go. Now we have our square or our cubes, and we still have that one that's really distorted because of our order of transformations. So there you go. That's abstracting every single thing into a class here. And of course, the next step would be to simply take all of these and basically do this process inside of its own class. But right now we're reaching like the 30-minute mark on this tutorial, so I'm gonna go ahead and save this for the next video. I promise the next video will not take as long as this one did. I won't be graduating again, so don't worry about that. It should be out very shortly. So with that being said, thank you for watching. I hope you found this useful. Have a good day. See ya.